Good afternoon, students. In the last class, what I sent in a video form, extend the point from that last lecture. Try to take these points. You are benefited to attempt the exam. Okay. I'll take the point now. The last class continuation. Now k value defined in earlier class, that is called the multiplication factor. If the k value is greater than 1, is nothing but the supercritical and explosive condition. K equals to 1, that is called the critical condition, and K is less than 1, that was named as under critical condition. Okay, now extend the point of this now. Now exclusive explosive chain reaction, explosive chain reaction is a working principle of is a working principle of atom bomb. Now another point now. Controlled chain reaction controlled chain reaction is working principle of nuclear reactor. Working principle of nuclear reactor. Note down those two. Nuclear reactor. Next one now. I'll take the nuclear reactor. Next one is nuclear reactor. It contains 5 important blocks. I'll summarize those parts now. Here I am writing. It is the 5 parts it contains. This particular column I define the part. The first part is called core. What it contains? Second column. It contains the nuclear reactor. It contains, that is nothing but nuclear fuel. It contains nuclear fuel. Okay, now materials. What materials you are used? Third column is material used. Generally we are using the material 92 uranium 235, 92 uranium 238. Next one 94 plutonium 236. Next one 96 thorium 232. Like this materials are used. What is the purpose of this core? The purpose of the core block is to produce fission. to produce fission, to produce fission. Go for the second block, that is called moderator. Second one is moderator, moderator. Moderator contains, what it contains now, a material of low atomic weight, a material of low atomic weight. Come to the materials are concerned here. Heavy water. Materials are used as heavy water. Ordinary water. Graphite. Okay na? Etc. What is the purpose of this? To slow down the neutrons, and promote chain reaction, chain reaction. That is the significance of the second important block, which is present in the nuclear reactor to produce the radiation. For various applications are there. Moderator, material used here, the low atomic weight. Material is heavy water, ordinary water, or the graphite, or anyone, to slow down the neutrons and to promote chain reaction. Now the third block is nothing but control system. Third block is control system. Now for this purpose, safety rods we are using. The main purpose is safety rods we are using. Now what kind of materials are used? Cadmium. Next one, boron. Cadmium, boron, etc. they are used. What is the significance? They absorb thermal neutrons. They absorb, not visible. Okay. Where it is not visible, which point? This one. Okay. They absorb. I write that point somewhere. They absorb, last column parameter again here. They absorb neutrons and control chain reaction. And control chain reaction. They control the chain reaction. That is the 3 blocks are completed, because already 5 units are coming in that. Now 3 units are over. Next one is the protective, fourth one. Now you continue the columns same format. Protective from rays. Protective from rays. Now here the material, the purpose contains 10 meter thick 10 meter thick concrete. 10 meter thick concrete. For this purpose, steel, lead, etc. materials are used. It is a purpose to prevent, its main purpose to protect the workers. To protect workers. To protect workers from the radiation. Because you are working there, it will protect you. And the last block, that is called the coolant system. Last block is coolant system. Now it contains what? High specific heat. High specific heat. High specific heat and high thermal conductivity. High thermal conductivity. High thermal conductivity. That kind of coolant we are using. Now come to the high pressure liquid. High pressure liquid. High pressure liquid. Come to the last one to remove the heat. To remove heat. The last column is to remove heat. These are the main parts which are present inside the nuclear reactor. The first one is called the core. Second one is named as moderator. Third one is called control system. Fourth one is called protective from rays. And the last one is coolant system. With the help of this whole 5 units together, then possible to perform either nuclear fusion or the nuclear fission. Okay, fusion or fission process. That is the point relevant to the nuclear reactor. Now, I will go to some more points now after the discussion of this nuclear reactor. Now the reactors, different types are there. Reactor types. Different types of reactors are there. One is called the research reactor. Research reactor. Second one is called, first one is a research reactor, second one is breeder reactor. Breeder reactor. First one is called the research reactor, breeder reactor. Third one is called power reactor. Power reactor. These are the 3 main types of nuclear reactors. The first one I define that also. What is that? Research. Research reactor. The purpose of the research reactor, I tell you now, they produce neutrons. They produce neutrons and radioisotopes. And radioisotopes. And they produce radioisotopes needed for research. needed for research. Example, one of the example only I tell you now. BARC Atomic Research Center, BARC, is told that. Apsara, APSARA, BARC, Apsara, Purnima. These are the different research laboratories where to produce the neutrons and radioisotopes. So many uses are there, radioisotopes. I tell you that point separately. Radioisotopes. That is the first functioning of the research reactor. Then I go to the second one now. Breeder reactor. Breeder reactor. Breeder reactor. Now first thing, it converts breeder reactor. Converts non-feasible material. Non-feasible material. Non-feasible material like uranium-238, like uranium-238 into feasible material. Feasible material like plutonium-239, Pu-239, and also generate electric power, and also generate electric power. And also generate electric power. Now the action here is 92 uranium-238 plus 0 N1, then goes to 92 uranium-239, that goes to 2 beta minus, then the value 94 plutonium-239. By following this sequence, it will convert non-fissionable material into fissionable material and also produce the electric power. That is the functioning of which one? Breeder reactor. Then I go to the last reactor now, that is called power reactor. Next one is power reactor. Power reactor. Next one is power reactor. Now here, these are used for generation of electric power. Used for generation of electric power. These are used for generation of electric power. Now here 2 points are coming now. The output power of nuclear reactor. Power of nuclear reactor. P equals to NE by T. P equals to NE by T. I will tell you each point significance. N means number of fission. Number of fission takes place takes place in time t. In time t. And E is energy released. Energy released for fission. For fission. For fission. The significance is this. Any output power of the nuclear reactor, NA by T, where N is called number of fission takes place in time T, is energy released for fission. Energy released for fission. Now, second point relevant to this is power reactor. One more point relevant to the power reactor is X gram of nuclear fuel of mass number capital A, of mass number capital A, undergoes fission in a time t, then energy released per fission. Energy released per fission. Then the output power. P equals to NE by T equals to X by A into N into E by T, where N is called Avogadro number. N is called Avogadro number. It is another form to define the value of X gram. At the time, calculation of power formula like this. Next one. Previous class I covered the point of nuclear fission.